Hello, I'm humbled to be presenting from the occupied homeland of the Lenape, Shawnee, Wyandotte, Miami, Ottawa, Potawatomi, and other Great Lakes tribes, and to acknowledge the thousands of Native Americans who now call Northeast Ohio home. My name is E, and I'm the Director of Infrastructure for the Python Software Foundation, or PSF. The PSF is a U.S. 501c3 nonprofit that serves the Python community through our mission to promote, protect, and advance the Python programming language and support and facilitate the growth of a diverse and international community of Python programmers. We currently fulfill this mission by holding and defending the trademark, copyright, and intellectual property for the Python programming language, awarding grants to support Python-focused groups and events around the world, providing fiscal sponsorship to extend tax-exempt status and back-office support to mission-related organizations, producing and underwriting PyCon US, and operating the online infrastructure of the Python community. In my role at the PSF, I'm responsible for many of the online services that Pythonistas around the world use on a daily basis. I don't necessarily build or develop all of them, but work to support volunteers that provide the community services on the python.org domain. Today, I want to talk about PyPI. To some, and with a nod to our conference director's wit, the cheese shop. Yes, it still redirects, but humbly, my preferred description is PyPI, where Python developers go to cheat on their homework. Alas, PyPI is the Python package index. It's the de facto place to find, install, and publish Python packages online. Richard's initial invitation to give this talk prompted for stories from the PyPI trenches, of which there are many. I've been a caretaker for the service for around 8 years at this point, primarily focused on the bits and bobs behind the scenes that are needed to keep the service online. In that time, I've contributed to 2 major infrastructure overhauls and migrations, the rollout of a full code-based rewrite, and a handful of major deprecations. During this time, I've also been there as the person carrying the pager on the front line for incidents impacting the availability of the service. So yes, there are many stories from that time in those trenches. However, in considering the opportunity to deliver a keynote for PyConline Australia, trudging through a decade of outages, security incidents, deluges of spam, and high-profile branded software development lifecycle and delivery attacks, and even our own mistakes, simply seemed like it would have been uninspiring and wasteful of the opportunity to talk about the successes that PyPI has seen, how we as a community got here, and what challenges PyPI currently faces, and how we can keep things going 18 years after the service initially launched. So with that, here's an outline for the rest of this talk. I'll share an overview of PyPI's history from my perspective, highlighting some of the critical changes that made it what it is today and quantifying the growth that it has seen. We'll take a look at the current era of the service and some of the challenges that it faces today, and we'll consider the future of PyPI based on that. Fundamentally, the core goal of PyPI hasn't changed since it was described and implemented in the early 2000s. PyPI came into existence as a solution to the problem of where do I find Python software? And while predecessors existed, they didn't offer the standardization necessary to programmatically upload, classify, find, and use this information. So given that, Richard Jones submitted Python Enhancement Proposal, or PEP 301, package index and metadata for distutils in October of 2002. A prototype was quickly developed and deployed, with the first submission to PyPI coming on November 1st, 2002, 8 days before the PEP was accepted, and about 12 hours after the first commit to version control that I could find. And thus, PyPI was born. Here's the earliest capture of the page by archive.org. At this point, PyPI is fulfilling PEP 301. Maintainers of software can register their projects and create new releases. Users who want new Python software can find and install it from here if they're using the latest Python. By the end of 2003, just under 300 projects exist on the index. This slide reads as intended. This is the point in PyPI history that I always like to pause at and enjoy. Imagine, it's 2004. Right now, PyPI is a pure hypermedia dream compared to what it's like to run a web service in modern times. Maintainers are responsible for hosting their downloadable artifacts, and PyPI is just a centralized index that allows others to programmatically search and find projects. The database is still just an SQLite file. What strikes me most about this moment is that theoretically, given the advancements in internet infrastructure since this moment, PyPI as it existed probably could have been served from the co-located server it was hosted on from that day to the present. As a point of interest, that very server, located in the Netherlands, was decommissioned early last month. And so that brings us to the first fundamental shift for PyPI since its inception. Even given steady growth of the index as far as submissions and usage by the community, self-hosting files was something that not every maintainer had interest or even means to do. As such, in March 2005, the ability to upload files to PyPI itself was added. And the inflection in this curve, showing total project counts submitted to the index, makes clear that this was the right thing to do. People wanted to share their Python software, and hosting was clearly a barrier that was keeping them from being able to do so. Thus, adding upload hosting was a good thing. But it came with caveats, and those caveats include the infrastructure necessary to store these files, humans to ensure good backups, and recover from disaster if necessary. All of which were available thanks to the volunteers working on PyPI and the hosting provided by XS4All at the time. So, I don't mean to gloss over the efforts of the many volunteers and contributors that worked to develop, maintain, and support PyPI in the interim, but from 2005 to around 2013, not much really changed about PyPI or its backing infrastructure. But what did change is that it got a new coat of paint to better match the Python.org of the time. Oh, and the popularity and adoption of Python, and thus the Python package index, saw extreme growth. At this point, PyPI had just over 36,000 projects, 185,000 releases, and about 62 gigabytes of stored files. The specific data and number on those graphs are interesting, but for the sake of this talk, the most important thing to keep in mind is the pattern of growth. There was a time, and will be again, when cognizance of the consequences of exponential growth won't be quite as ubiquitous as they are today. But as you can imagine, this kind of growth without a major overhaul of PyPI's infrastructure led to painful results for the community. By 2010, PyPI was suffering outages frequently enough that official mirrors of PyPI had been commissioned and were being maintained by volunteers to provide fallback as needed when PyPI itself was unresponsive. These outages directly impacted all users of PyPI, making installations and downloads impossible, as well as stopping maintainers from being able to publish their own latest releases. This post by Jacob Kaplan Moss was a common response on Twitter to help listless Python programmers keep moving despite the flakiness of the service. Mirroring did carry the community for many years, but ultimately, what PyPI, at this point, firmly a core piece of internet infrastructure, needed was, well, infrastructure. Hosting improvements in 2012 to migrate from those co-located servers to a private cloud at the Oregon State University Open Source Lab provided online redundancy and scalability to PyPI for the first time, after a decade of being online. This effort, led by Noah Kantrowitz, did provide substantially more resources to the backends, taking off some of the pressure. Unfortunately, the demands of the other Python services being hosted at OSU OSL and the limitations of PyPI codebase itself meant that for parts of the backend, the scaling up needed to meet the demand wasn't feasible in this environment. And in January 2013, the Python wiki host was attacked, leading to a security breach and a complete loss of the data stored there. This led to a commitment by the Python Software Foundation to fill a part-time systems administrator role for the PSF infrastructure. Myself and Benjamin Smith applied for this role, committing 130 hours of paid work per quarter and sharing a 24-hour on-call rotation to respond to incidents. In February 2013, we were hired for this paid role. It is ultimately what latched me into the Python infrastructure. From that point forward, I began to put work into ensuring the PSF infrastructure paged as little as possible, for reasons which should be obvious. And much of that work ended up being focused on PyPI. That didn't change that the resources in our hosting environment weren't keeping up. Far and away, the largest infrastructure improvement PyPI has ever seen is the implementation of Fastly as a CDN, or Content Delivery Network. The commitment Fastly has made to supporting the open source community that they themselves benefit from is outstanding. In May 2013, Donald Stuff flipped the switch to move PyPI behind this CDN. Unfortunately, statistics for PyPI's usage before this point are likely lost to history. But the statistics from Fastly that we do have, we can see just how dire the infrastructure situation was and how badly a CDN was needed. In its first full day serving as the edge for PyPI, Fastly served 5.6 million requests and almost 800 gigabytes of data transfer on behalf of PyPI, with over 2/3 of that traffic being diverted from our backends. In its first full month, we start to get a better idea for the scale that PyPI was already at in 2013. If you have a calculator, that's around 85 requests per second, which isn't unheard of for a single server nowadays, but given the limitation of PyPI's implementation at the time, it's very impressive that it was staying online at all before the CDN. And more stark is that data transfer. For anyone who's ever paid a hosting bill, I'm guessing you might be getting nervous right now. The success of PyPI's CDN rollout with Fastly and the reliability provided for installs to continue even when PyPI itself was down allowed for the deprecation of those official mirrors of PyPI in the second half of 2013. Aside from the simplicity provided for end users, this also addressed the outstanding security concerns of the mirroring infrastructure. And in late 2013, the PSF and PyPI were some of the first benefactors of Rackspace's open source support hosting program. This, combined with me having committed and paid time to work on the infrastructure, led to a complete rebuild of the PyPI backends onto Rackspace's public cloud. The final result was a failover capable backend that we could scale out as needed to meet the demands as PyPI continued to grow. While outages naturally continued for PyPI itself, they became less frequent and generally were resolved more quickly. But outages for the hosting solutions chosen by maintainers who opted to host their own files also led to confusion and frustration throughout the ecosystem. Remember that supporting direct uploads to PyPI for it to host was just an additional feature. In the 13 years that PyPI had been online, many externally hosted files had either gone missing or were hosted on flaky or insecure infrastructure. With the reliable CDN and less outage-prone backends, 10 years after PyPI started to support uploads, PEP 470 was proposed to disable external hosting altogether. PEP 470's acceptance and rollout effectively completed the core feature set that we know from PyPI today. So overall, with commitments to the infrastructure by volunteer contributors, community-based support, companies via in-kind sponsorship, and the PSF financially supporting that infrastructure, 2012 to 2014 provided a foundational shift for PyPI to grow into a more reliable service for the community. And grow it did. With careful tweaks and optimizations like internal caching, migration of file storage to Amazon S3, removing non-critical features, PyPI saw a continued growth trend from mid-2013 on to April of 2018, with minimal fuss to keep the lights on. Here you can see a 4,000% growth in daily request volume and nearly 5,000% growth in daily data transfer during that time. So this brings us to the end of PyPI's first 15 and a half years. Collectively, we can call everything up to this point the history of PyPI. And quite frankly, even with the bumps along the way, it's hard to call it anything but successful. By the time we reach the end of this era, PyPI hosts 140,000 projects, 975,000 releases with 1.3 million release files, just over a terabyte of data. I think it's worthy of a moment to reflect on just how far PyPI came on a shoestring budget and skeleton crew to this point. For over a decade and a half, PyPI was able to grow exponentially to meet the needs of the Python community with resource limitations that are hard to imagine. We owe immense gratitude to the people who made this possible. But the truth is, by this time, the codebase and infrastructure behind PyPI were starting to show their age. It was becoming harder and harder to onboard new contributors into a codebase that was still architected with valid assumptions from 2002. At that time, none of the robust web frameworks or standards that we take for granted today existed. So PyPI used what was available and logical at the time. Even for those of us who contributed to PyPI on a regular basis, the codebase made building out new features cumbersome, and a lack of thorough tests made deployments risky. So realistically, this entire era of PyPI's history was mainly about keeping the lights on rather than developing new features to support the Python community. For a fairly comprehensive summary of the state of PyPI at the end of this phase of its life, I recommend checking out Donald Stuff's post, Powering the Python Package Index. So that brings us to the current era of PyPI and a new set of challenges facing the service. By now, most of us are familiar with this visage of PyPI, and for those not paying attention, the transition into the current era of PyPI may not have registered as the massive undertaking it has been. This era began rather quietly with Donald Stuff joining Hewlett-Packard Enterprise in 2015. During Donald's 18 months there, Hewlett-Packard allowed him a full-time commitment to Python packaging. In addition to a plethora of work done throughout the Python packaging space, Donald started the undertaking of a complete rewrite of PyPI's codebase based on his previous prototypes and packaging work. Today, that effort is what powers PyPI, and its name is Warehouse. Donald set out with ambitious but clear goals for the project. Nearly all of them have been realized and upheld to this day. Some of the most notable are comprehensive test coverage, extreme cacheability, a modern web framework, security-mindedness, and up-to-date dependencies, creating a maintainable and extensible codebase. But for anyone who's been part of or witness to a full write of an existing codebase with ambitious goals, it should be obvious that such an effort isn't trivial or fast, especially with a committed team of approximately one. So ultimately, the effort reached the point in 2016 where Warehouse could do most of the things a PyPI needed to do, but didn't have entire portions of features necessary to replace the existing codebase. At around this time, having identified that finishing Warehouse would require committed resources for development, design, and crucially, project management, Donald, along with others, co-founded the Python Software Foundation Packaging Working Group. This working group was formed to support large efforts in improving and maintaining the packaging ecosystem in Python through fundraising and grant oversight. By forming this work group, the PSF was able to provide crucial administrative support necessary to apply for and deliver on substantial grants and awards for work in the Python packaging ecosystem. The very first of these that the packaging working group successfully applied for was the Mozilla Open Source Support Awards program. In their foundational technology track, a $170,000 award was funded to complete development of feature parity for Warehouse, migrate PyPI to run from this codebase, and decommission the original service. All of this was accomplished under budget in the allotted 5 months with a team of 3 developers and a project manager. In addition to the deliverables of the award, there were incredible byproducts in community engagement, contributor onboarding, and extensive improvements to the documentation for PyPI users and developers. In large part, the success of this work is due to the influence of Sumana, our project manager. So, from my perspective, the true start of the current era of PyPI began on April 16, 2018, when Warehouse went live as the PyPI. And the results of this current era have consistently met the goals for that rewrite. One of these goals was to make funding development of PyPI appealing via grant and award applications by the Python Packaging Working Group. Carrying on from the success of the MOS Warehouse Award, the PSF Packaging Working Group has gone on to apply for and receive funding for multiple additional projects. In 2018, an $80,000 contract was proposed by the PSF Packaging Working Group to the Open Technology Fund's Core Infrastructure Program. This work would be completed in 2019 and brought some of the first major new features to PyPI in years. On the security front, it delivered multi-factor authentication via TOTP and WebAuthn, API tokens for uploads, and enhanced audit logging for projects and user accounts. To help make PyPI more readily available to the global Python community, this work also delivered an accessibility audit and accessibility fixes. It enabled localization features and provided tooling for community translations of PyPI. So now, among the 13 languages PyPI is available in, you can browse in German, Spanish, and even Australian. Underway right now, thanks to a $100,000 gift from Facebook Research to the Packaging Working Group, is the implementation of the update framework per PEP 458. This gift also funded development of infrastructure for automated analysis of package uploads, along with prototype malware checks. And worthy of note, this track record also enabled the Packaging Working Group to simultaneously and successfully apply for both the Mozilla Open Source Support Awards program again, as well as the Chan Zuckerberg Initiative's Essential Open Source Software for Sciences program, to fund a total of $407,000 worth of work on PIP in 2020. The reason I note this is that it is the first time that the PSF Packaging Working Group successfully secured funding for a project aside from PyPI, thanks to the experience gained in funding PyPI itself. This is a major milestone in fulfilling the Packaging Working Group's goals. Now, all of these improvements are incredible, and as a community, we are benefiting from them. However, some of the biggest wins since PyPI was relaunched have been in the maintenance of PyPI itself. A new administrator, bringing our total up to 3, a new team of 5 moderators who can help triage support issues and perform tasks that were previously only doable by admins, a new team of issue triagers who can help keep our issue tracker in order, a new team of translation project maintainers, and over 100 contributors to translating PyPI, nearly 80 unique contributors to the PyPI codebase since its release. Once again, I'm glad to be able to point you to another of the PyPI administrators, Dustin Ingram, who does an excellent job summarizing the current state of PyPI in this era. So, all in all, I think celebration of the results we've seen is warranted. As a codebase, the effort put in has rewarded us with something extensible and maintainable that truly is PR's welcome. Now, this isn't to say that this is a happily ever after story yet. We still have some fundamental challenges that we face in the current era. Many of these are open questions, and frankly, we don't have solid answers for how to overcome them at this time. The first is user support. While our team of moderators has been crucial in helping us stay up to date with routine requests and basic issues using PyPI, there still remains a large backlog of requests which are either security sensitive or require administrator access to resolve. This is the unfortunate reality of there only being one person who's paid to support PyPI as it continues to experience a growing user base. Not to mention, it's only a slice of that paid person's time. So many of these backlogs are blocked on them. The next is project management. PyPI has seen its greatest strides forward under a reliable project manager. All of our successfully fulfilled grants and awards incorporated some amount of project management in order to see them through. In 2020, we had to take a step back from applying for and undertaking funded work, as the overhead of project management within the PSF was taking a toll on other initiatives. With that, we currently have one stalled project and substantial funding from Google that is waiting until we're in a place to responsibly start that work. And you may have noticed a pattern in the graphs shown to quantify PyPI's growth so far. And indeed, that pattern has only continued. As of the end of June this year, PyPI currently hosts over 312,000 projects, 224,000 releases with nearly 2.7 million release files, and 7.5 terabytes of data storage. The growth in the size of data storage has far outpaced most of our other metrics. While we have identified some of the drivers of this growth and are working with those publishers to hopefully address their specific use cases, large files, specifically binary wheels, are becoming more and more common on the index. This has not only been taking up moderator time, but we currently have some technical constraints that make turning the knob further to grant higher limit requests untenable past our 1 gigabyte max limit currently. But mostly, these large distributions have reached the point that they're having knock-on effects, most notably in data transfer. In Q2 2021, PyPI served a staggering 62 petabytes via our CDN. Even with a cache hit ratio of 99% and Fastly providing that data transfer for free, the 1% of traffic to our backing store for files is substantial enough that the growth in data transfer consumption necessitated a quick migration of our backing object store from Amazon S3 to Google Cloud Storage. This migration allowed us to leverage interconnect partnerships that Google Cloud Platform has with Fastly in order to be better stewards of the donated resources that make operating PyPI possible. Data transfer alone was quickly consuming the generous credits we have with Amazon that allow us to run PyPI's backends there. So I'd like to take another opportunity to extend a heartfelt thank you to Fastly from everyone who works on, maintains, supports, and uses PyPI. While our growth has been a challenge, only 1% of that actual growth is felt at the PyPI backends. This has enabled us to be where we are today with the limited resources that we have. What PyPI does would not be possible without Fastly. So that's more or less what PyPI has been up to over the past few years. And frankly, at this point, it's safe to say that the code base behind PyPI has reached a point of sustainability. And ultimately, that is the greatest success of this current era of PyPI. But the sustainability of the software is independent of the sustainability of operating the service. This challenge is the one that I believe must be addressed in the next era of PyPI. So, I know it's taken some time for us to get to this point, but it's the crux of what I want to motivate here. To activate the entire Python community to think about how we can collectively enable the operational sustainability of PyPI into the future. When I use this term, I'm focusing primarily on what it takes to keep PyPI online and available for the community. Realistically, we can break this down into three major components: the human labor necessary to operate the service, respond to incidents, and support users; the finances to cover month-to-month expenditures, pay for improvements, and compensate the aforementioned labor; and the organizational structure to help manage those concerns. The Python Software Foundation has served as the organizational backstop for PyPI since its inception. Initially, this didn't entail much, but in the past 10 years, the PSF has taken on more and more of a role in ensuring that PyPI stays online. This not only includes the work that the packaging working group has done, but also hiring me. Now again, I have to make clear that my full-time job is not just PyPI. It's a relatively small fraction of what I do on a day-to-day basis. All other labor that goes into PyPI is community and volunteer driven. Some work is done by employees of companies, but those engagements tend to be driven by scratching an itch for a single feature, Or occasionally there are people paid full time to contribute to open source that choose to spend that time contributing to Warehouse. But the current state is that we only have me and only part of my time paid to operate the service. I don't think we can call that sustainable. And if you know how often I ride a bicycle, you might call it downright risky. Now, excluding my salary and overhead internal to the PSF that we'll discuss shortly, the monthly cost that the PSF pays to run PyPI is an earth-shattering $0. Well, kind of. As it is, we are grateful to have these companies who provide in-kind sponsorship of PyPI by letting us use their services at no cost. These relationships are either off-the-shelf offerings provided to any open source project, or for some of the larger ones, formalized sponsorship agreements with the PSF. Managing sponsorships creates some overhead costs within the PSF that we absorb as part of running our broader sponsorship program. But in the interest of sustainability, we have to keep track of the value of these donated services. So let's look at August of 2021, just last month. Here's what it would cost if the PSF paid out of pocket to run PyPI for that month. $8,000 in servers and hosted data stores on AWS, $5,000 to run our analytics pipeline on Google Cloud Functions and store that data in Google Cloud BigQuery, $4,200 to store upload files and the data transfer needed to serve them to our CDN, and about $1,000 in tooling for monitoring, error logging, telemetry, and communications when things go down. So in the last month, it would have cost around $18,000 for PyPI. That is, however, excluding what our CDN cost would be if we paid Fastly retail. And if we remember back to earlier growth graphs, it shouldn't be surprising that the monthly retail cost for PyPI CDN is following a similarly alarming pattern. So I think the hard truth is that we must admit that the current status of PyPI is not even remotely financially sustainable. If there came a time that one of our in-kind sponsors abruptly ceased providing the resources at no cost, depending upon which service it was, PyPI is designed from the ground up to abstract itself from operating on a specific brand of any given dependency. So, while myself or another contributor work to implement a new integration and migrate to a new provider, the PSF would be on the hook to pay the bill for those services in the interim. Now, that in and of itself is not a problem, as the PSF has worked diligently to build a reserve of funds over the last decade to ensure that critical parts of the Python community can survive in the face of financial disruption. So, considering the retail cost to operate PyPI, all but one of those services would be tolerable for the PSF to cover for a few months at most. But if the PSF ever had to pay PyPI CDN bill, almost regardless of the provider, that bill would be more than 50% of our reserve in a single month. The impact that 2020 had on the PSF's reserves is obvious. For the first time, a major block of those funds was necessary to continue the operations of the nonprofit, primarily as a result of the lost revenue from PyCon 2020's cancellation. In June, at the end of PSF's 2020 fiscal year, assets were around $4 million. The very risk to our financial sustainability directly risks our organizational sustainability. So, in assessing the operational sustainability of PyPI, it's very hard to make a case that we have such sustainability. And in the aftermath of PyCon 2020's cancellation, the PSF remains committed to ensuring the sustainability of the nonprofit itself, and also PyPI. We believe that those concerns can be accomplished hand in hand. While we haven't made any firm plans on what the future of PyPI looks like, there are some things already in motion with the intent to build towards a more sustainable PyPI and more sustainable PSF. The PSF revamped and relaunched our sponsorship program in 2020 to include benefits related to PyPI. As a result, a portion of sponsorship funds are now earmarked for PyPI. This is a departure from the past, where all sponsorship funds were part of the PSF General Fund, requiring board approval to spend on the service. Also on the sponsorship front, PSF visionary sponsor Bloomberg, in addition to their direct sponsorship of the PSF, committed to $250,000 in funding for a Python packaging manager role to be fulfilled at the PSF over 2 years. And in great news, in August, Shamika Mohanan started at the PSF as our packaging project manager. In this role, Shamika will be working on efforts similar to the funded work that the packaging working group has undertaken over the past 4 years, and begin liaising as a community manager with the broader Python packaging ecosystem to help with initiatives throughout the space. But a critical component of Shamika's work will also be in helping the PSF to build a more sustainable PyPI. Now, this is the place where we face the most uncertainty in looking forward for PyPI. I hope by this point we can agree that while PyPI has made enormous strides in becoming sustainable as a piece of software, operating the service as is simply can't be sustained indefinitely. So what are our options and what will we explore? Perhaps the status quo is sufficient. We've seen success in securing funding for big lift efforts, retaining in-kind sponsorship, and squeaking by with the volunteer and paid labor that's available. And honestly, no matter what, we will probably continue to do these things. But historically, that has led to what we see over the past 18 months or so for PyPI. When large-scale funded efforts are complete, the people who are paid to do that work go on to do other paid work, meaning the effort to reconstruct teams when the next round of funding is available is duplicated time and again. We hope that having a packaging project manager to focus on this sort of thing can alleviate some of that duplication, but it doesn't change the fact that we still need to hire or rehire contractors based on their availability. We're very lucky to be a high-profile enough service that retaining in-kind sponsorships isn't necessarily hard, but it doesn't do anything to mitigate the risks of those sponsors choosing not to continue their support. And lastly, the results of relying on a skeleton crew are simply not sufficient to keep up with the growth that PyPI is seeing. So, unfortunately, the status quo just isn't working. It leads to stagnation and even getting behind on improvements to PyPI because what limited resources we have, once again, end up focused on maintaining the service and keeping the lights on. So, maybe it's a case where small iterations and changes could make up the difference. More talks like these, or features baked into PyPI that make clear what the true cost of running the service is, and ramping up donation efforts, and seeking sponsorships to support the service. And here, we've already started on some of those things, and we know that they'll remain important in supporting the Python community at large, while also helping to sustain PyPI. The barrier that I keep running up against when considering what a sustainable PyPI looks like is that all of the efforts we've undertaken and all of the iterative improvements are not directly tied to the growth of PyPI. Of course, as Python and thus PyPI have grown in popularity, our ability to fund projects, attract new contributors, and retain sponsorships have also grown. They're just not growing in the same manner. These graphs should illustrate that. The overall trend for PSF sponsorship compared to the trend for usage on PyPI, as illustrated just by data transfer, indicate that we have one that is linear at best and one that is, well, exponential. So there's a case to be made for establishing some mechanism by which the funding available to PyPI actually correlates to its popularity and use. And that's what motivates us to begin considering the ways that we can responsibly implement features on PyPI that will provide real value for corporations while benefiting the community as a whole. By creating a new revenue stream for the PSF, we could become less resilient on PyCon to fund our mission. Any revenue generated by PyPI must initially go towards addressing some of the challenges we currently have. It means potentially an entire paid team working to operate PyPI and support all users of the service. Over time, if things go well, it could reach the point where PyPI is sustaining itself. That's our long shot goal. In preliminary discussions exploring this topic, there's clear consensus on some requirements. None of these features should impact reasonable use cases of PyPI. However, being realistic, there are almost certainly some use cases that are extremely niche or far enough beyond the reasonable limits of the service, either by accident or intentional, that may require intervention. All paid features will have to be available to community organizations at no cost. We don't see the point in developing a feature for PyPI that doesn't simultaneously support the community that we serve. And lastly, all of these features should be developed on actual needs in the community. Again, none of this is set in stone yet, and in the coming months, our packaging project manager, Shamika, and myself will be working on outreach needed to fulfill the requirements and understand what a roadmap for this kind of initiative looks like. And in all honesty, there are significant risks to pursuing a paid PyPI at all. It must comply with our nonprofit status. It may alienate volunteers who work to support and contribute to PyPI as it is. Our sponsors, both in-kind and direct, may no longer support us. And frankly, there may simply not be the demand that we anticipate for such a feature. So that's the big reveal. Although for those who pay close attention to PSF, the idea was already leaked in our annual impact report for 2021. Now, I want to leave you with some ways that you can get involved with all of this. I'll have URLs on the next slide where you can go for each. The first is to donate. The PSF is and will remain a nonprofit. Every donation we receive goes to continuing to fulfill our mission, including operating PyPI for the community. Sponsor. Encouraging your company to sponsor the PSF can amplify your impact year over year with more continuity than relying on individual donations provides. Contribute. PyPI is and will continue to run as an open source project. And open source projects need much more than software development. We always need help and input from every imaginable skill set, not just back-end development. And discuss. If you're not familiar with the Python discussion forum, but are interested in packaging and PyPI as a whole, please take some time to find us there. Participate in existing discussions and be on the lookout for announcements as we enter research phases for the future of PyPI. And with that, I want to thank the organizers of PyConline Australia, the volunteers helping run the event, and the sponsors that help support this conference. And finally, you, the attendees, for taking the time to be here.
And we're back. We're back. Excellent. Look, thanks, E. That was fantastic. And look, I hope it gives some folks some ideas of where we've been, how they might contribute, and some of the very exciting future of the Python package index in the future. And E is joining us from a camp. Look, I just want to say that as a child of the 1970s, have our conference keynote call in from a campsite to chat with our about 700 attendees is frankly mind-blowing. So welcome, E, to the conference.
I'm actually baffled that it worked at all. It's a pleasure.
All right. Well, look, what are you up to there, E? Just out of curiosity.
I'm gonna ride my bike an excruciatingly long distance tomorrow, and I had to drive an excruciatingly long distance to be here. Thus, I'm camping before.
Fantastic. I'm an avid follower of your bicycle antics, so have a heck of a fun ride.
Thank you.
We have a bunch of really good questions that have come in from people watching the keynote, so let's get on with those. Look, the highest ranked question is, are there any security concerns when downloading a random package from the Python package index? How careful should I be?
Yes, I would say that simply choosing a random package to download comes with a random amount of risk. Because PyPI is designed to be a public and freely available service and intends to remain that way into the future, anyone is able to upload anything they like there. And because of the like constraints of packaging in Python and the tooling that exists, that means that executable code, whether it's at install time or runtime, is always a risk. Just in the same way that any bug or system crashing feature could be as well. So the amount of risk that is reasonable when you're installing something that or that has good what's the word for that? Whatever, has a good lineage, it came from somewhere that you're familiar with, is fairly low. Choosing a random package off of the index is kind of risky, because it is just as it's just as free as the internet in that way.
Yep. Very solid advice. Our next question, I've always wondered this. Why did PyPI not have hierarchical namespaces like CPAN? I take responsibility for that partly. But what
So
what do you say?
And there was no need sort of assumed for such a thing. Thus, it was implemented and delivered immense value for a long time without namespaces. Namespaces are a good idea. We should have more of them. Is a very important string that most of us are somewhat familiar with from the ZennaPython. But why doesn't it have them now is effectively the question of the cost and time to implement them and the return on that. And so effectively, it's something we recognize as having an importance in the future of PyPI, not only because the amount of space on the index is slowly being exhausted as far as just the number of strings go, or the number of usable strings go, but also because it creates credence for projects. So if a corporation is able to have a namespace that matches their corporate Similarly, community projects like Django, for instance, should absolutely have the ability to publish under their own namespace. And so that's the sort of thing that we're really seeing as like a very high potential for paid features on PyPI, is to allow corporations to own their namespaces for a cost and allow community projects to own their namespaces at no cost.
We have an amazing keynote. That's more of a comment than a question, but it does come with a question after it. So amazing keynote, thank you. Just to kind of reiterate, what support does PyPI need from the community in 2021 and beyond?
Yeah, certainly. I think that there are a couple crucial things people can do immediately, tomorrow, and the next week, and then some things that are definitely important over the coming weeks, months, years. Immediately is talk to your company. If you work at a company that uses Python and thus uses PyPI almost assuredly, talk to them about sponsoring the PSF. It's by far the most direct way that you can have impact today. In the coming days and weeks, it could be contributing to the code base, helping us to resolve some things, taking some time to get familiar with it and deliver a feature or a bug fix that is valuable to the project. In the near term, there's going to be a pretty big research phase around how to responsibly and appropriately approach paid features on PyPI. So engaging that is a really great way to get involved. And then the long term, start paying for those features if they make sense for you.
Fantastic. We are just pushing over 10 o'clock, but I have one more question, which is a little bit dear to my heart, and I wonder if you might have a quick answer to it. Is there any data on how much of the traffic is caused by CI jobs downloading the same package hundreds of times a day?
I don't think we have direct data for that, but there are features in pip that were added some time ago that will help us answer those questions. And so if you're interested in answering that question yourself, you can go look at the documentation for the BigQuery dataset that Google helps us publish for PyPI download statistics. And one of the little bits of metadata in there includes pip's best guess as to whether or not that download is instantiated from a CI. So it's something that is theoretically answerable on an approximation with that data set, but there's nothing we can say unequivocally.
There's a related question to that, which I'm going to slightly paraphrase because it's vendor specific, but I believe that other vendors would be interesting to talk about here. But would it be worth talking to, or have we had conversations with vendors like GitHub to see whether or not they could have their own caches sitting between them and the cheese shop?
Yeah, so I'm almost positive that there are corporations out there that instantiate such mirrors or caches between. I'm not familiar with any continuous integration servers that do so. I do. I'm fairly certain that continuous integration is a big part of our bandwidth consumption, as is mirroring, and as is just, again, the popularity and usage of Python. So it's not something that I think we can be. Thank you for those links in the chat, by the way. So it's not something, again, that we can be positive about the answer to, but it is absolutely, if you run your own continuous integration jobs and have control over a cache, that contributes, right? If you're able to start caching your, pips wheel cache between builds, that can be a big advantage for you, and also contribute to lowering that bandwidth overall.
Yep. I think what we might do is call time there on this live chat and switch over to the text chat where we can continue having a more asynchronous conversation and people can go off and grab a coffee. We'll have a little bit of a break before we cut into our next set of talks. The next session is due to start at 10:30 Australian Eastern Time, where we'll have those two tracks that I talked about earlier. Kicking off. Oh, I've lost my window. Where are we? Here we go. I've got too many windows open. So yes, we'll take a break now. Thank you again, E, for that wonderful, wonderful keynote, enlightening and inspiring. And we'll catch you in the text chat. Thanks, everyone.
Thank you.